Now let's take an example of predicting a continuous variable, which is price of a house. So a price of a house can vary from any number starting from 1 to n numbers. So which means there is no limit for any price of a house. So it can vary from any number. So that's where it is a continuous variable. So to predict a continuous variable, the algorithm that we have to use in machine learning is linear regression algorithm. So linear regression algorithm is something which is used to predict a continuous variable given the independent variables which can be able to influence the price of a house. For an example, as you could see on the screen, we're trying to take one independent variable, which is square feet of the house, that can predict price of a house, which is a continuous variable. So in reality, it is not that only square feet of the house will only can judge or can predict the price of the house. There can be n number of other independent variables which can influence the price of the house. For example, number of bedrooms in a house and how far this particular house is located from for any public accessible points, or what kind of area it is, like whether it is a residential area, whether it is a commercial area, how old is this building, and whether it is a bungalow, whether it is a villa, whether it is an apartment, if it is an apartment, which floor it belongs to. So likewise, there can be n number of factors which can show influence on the price of the house, which are multi-dimensional data. So to understand about linear regression algorithm, we will take simple data which is in two-dimensional data, and we'll see how this two-dimensional data can be used to build a linear regression model. So to consider this two-dimensional data, I am going to take square feet of the house on x-axis and price of the house, which is our dependent variable, on y-axis. So now let's take some historical data. As we discussed, we definitely need to have some historical data to start with building any algorithm. So let's assume we have some historical data in this case. Let's say I'm going to consider square feet of the house on x-axis, price of the house on y-axis. So let's try to take some data points where our square feet of the house might vary starting from 800 square feet, 1000 square feet, 1200 square feet, or 1400 square feet, etc. On y-axis, I'm going to consider, maybe we'll take a price of the house maybe starting from 100k or 150k, 200k and 250k. So let's take some historical data points. Let's say there is a house which is of 800 square feet, which is costing around 100k. And there is one more house which is close to 1000 square feet, which is costing somewhere close to 140k on y-axis. And then we'll take few more data points likewise. We'll take few more data points likewise. Now let's say, for example, there is a new person who is having a requirement of purchasing a house of 1100 square feet. Purchasing a house of 1100 square feet. So considering our historical data, where our historical data points are only, there are only 5 people who are living in this area with so and so square feet of the houses. So considering that this particular new person who has a requirement of purchasing a house which is of 1100 square feet, and if you assume that okay, this person is going to individually go and talk to each and every person to give the predictions, maybe all these 5 people might give the prediction at this point, maybe somewhere close to 150k as the price of the house. And there is no chance that people will give predictions to the same person, maybe saying your price of the house can be somewhere close to 150 or 200 or 250. There is no chance that this kind of predictions can be given by the people. Obviously the person will get the prediction somewhere close to 150 because that is the most nearest data point to compare to the existing historical data points. And for another example, maybe another person has come up with a requirement of, hey, I want to purchase a house which is of 1400 square feet. Maybe the person can get a prediction somewhere close to 250k or 300k or maybe 270k, somewhere close to it, because as per the historical data, the outcome is more closer to the existing historical data points. So rather than an individual data point can be predicted with respect to the historical data points, I'm going to propose a solution where I'm going to draw a line in such a way that this line is going to go through most of the data points as close as possible so that I will get the predictions based on this line. So when someone comes and asks like what is the price of the house for this particular observation, maybe I can give a prediction straightforward on top by projecting this value on top of this line, and I can give my prediction as your price of the house can be of 155k. Or if some other person has come and then say like, hey, I have a requirement of purchasing a house for 1400 square feet, I will straight away project this value on this straight line and I will give the prediction as based on this straight line. So I will continue to use this regression line that I'm just referring to as a straight line. I'll just call this as a regression line that can help me to predict the price of a house given your input, which is x-axis as square feet of the house. So this is what we call it as a linear regression line, which can help us to give the prediction which may not be very much accurate to your actual value, but it will be very much, the predictions will be as close as possible to our actual values. So anywhere in predicting a continuous variable, we cannot build a model which can give very close or very accurate values where you can expect your model to give predictions as close as possible to the realistic values. So now how this linear regression algorithm will come up with the final linear regression model which is fit enough for your data, which can finally fit enough for your data, that can give you best predictions for your historical data and can give best predictions for the future data using the historical data points as its training data. It uses linear regression algorithm uses a method called a least squares error method to identify the best regression line that will give us the best predictions. So now let's see how we will come up with a linear regression model that can be built using least squares error method.